friends, welcome to engineering tutorial. So we'll continue our discussion related to electrical machines. So far we have discussed about various concepts related to electromagnetism, about the magnetic effects of electric current. We've discussed about magnetic flux density, the magnetic force, then about various laws which determine the magnetic field intensity, magnetic flux density at a point, Biot-Savart law, Ampere's circuital law. So in this video we are going to discuss about another important concept related to electromagnetic circuits, basically how electric and magnetic field combined together affects the operation of a circuit. Okay, so it will be very important in our discussion related to the operation of various electrical machines. So we'll be discussing about Lorentz force. Okay, so before we discuss about Lorentz force, first we have to refresh some concepts. We know that when a charge, okay, a positive charge, it moves with a certain velocity in a magnetic field. Okay, the magnetic field exerts a force on it, okay, which we have discussed in the first video in this series, and that magnetic force is given by this. Magnetic force is equal to Q V vector cross B vector. Okay, so here Q is the positive charge which is moving in a uniform magnetic field of magnetic flux density B, and the velocity vector makes an angle theta with the magnetic flux density vector. So it is represented here as this x, y and z axis. B vector is along y axis, it is represented, we have taken it along that. Then velocity vector small v, it makes an angle theta with the magnetic flux density vector. They both lie in the xy plane, and the resultant magnetic force exerted on that positive charge is in the direction perpendicular to the xy plane. Why? Because here the resultant vector is the cross product of v vector and b vector. So obviously it will be in a direction perpendicular to the plane containing the two vectors involved in the cross product, which is v vector, small v vector and b vector, velocity vector and magnetic flux density. So this is the magnetic force which acts on a charge when it moves in a magnetic field. That is the first part of this discussion. Now we have already discussed about Coulomb's law, about electric field intensity, about electric field lines, electric potential, everything we have covered in the electricity and magnetism, that discussion. You can check it out by clicking on that playlist, by checking that playlist. Now we know that the electric field intensity at any point in space is the electric force acting on a positive test charge at that point, or simply electric field is Coulombic force divided by charge. Simply that, force by charge. So as Coulombic force is exerted, given by Coulomb's law, Q and Q2 by the distance r square, so that's why we call it Coulombic force. So electric field intensity is simply Coulombic force by charge, or we can say that the electric force is simply charge multiplied with the electric field intensity. So this is the electric force exerted on a charge when it moves in an electric field. Okay, this is the second part of this discussion. The first part is the magnetic force acting on a charge when it moves in a magnetic field, which is this Q V vector cross B vector. This is the magnetic force acting on the charge moving in a magnetic field. Second is the Coulombic force or the electric force acting on the charge when it is moving in an electric field, which is this Q E vector. This is the magnetic force, this is the electric force. Okay, now Lorentz force comes into play where both electric and magnetic fields are present. That is the situation that we experience in the operation of electrical machines, because it is all about electric and magnetic fields, the conversion of one form to another, one form of energy into another, like that. Okay, so obviously there will be interaction of electric and magnetic fields, there will be movement of charge in electric and magnetic fields combined, that will cause the flow of current in the circuit. So Lorentz force comes into play. Now suppose a charge Q, it moves in the presence of both electric and magnetic field. Okay, in that case the total force acting on the charge, that is the sum of both the magnetic force and the electric force, that sum total, the total force experienced, is called as Lorentz force. Okay, simply Lorentz force, the sum total of the magnetic force and the electric force when both electric and magnetic fields are present and a charge moves with a certain velocity in that combined electric and magnetic field. So that total force, also called as Lorentz force, is given by the sum of the electric force and magnetic force. The electric force is simply product of charge and electric field intensity. This is in vector form. Magnetic force is charge multiplied with the cross product of velocity vector and magnetic flux density vector. So this expression is the expression of Lorentz force. So it is very simple, this whole thing, this discussion. Only thing to understand here is the Lorentz force is the sum total of these two forces. So that's why it was important, that's why I discussed the magnetic force first in the first video, and then we have already discussed about Coulomb's law and Coulombic force in the electricity and magnetism discussion. So just we introduced that concept here, and this is the expression of Lorentz force, which is because of movement of charge in the presence of both electric and magnetic field. And this concept will come into play in our discussion related to the operation of electrical machines. So at that point I will simply, when this whole concept will come, I will simply refer you to this video to refresh your concept. So that was the whole purpose of making this video and all the videos related to basic concepts related to electromagnetic circuits. So at any point if you feel confused, if you not able to recall the concepts when we discuss about electrical machines, I will simply be pinpointing you to the specific video in the I buttons or end screen or anywhere. I will simply pinpoint you to that video or that playlist so that you can watch the video as per requirement and refresh your concepts. So this is the basic discussion related to Lorentz force. So I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to engineering, science and technology. Have a great day. Thank you very much.